Now, the other application of Bernoulli's energy equation is the Venturimeter. Venturimeter is a flow measurement device which is based on the principle of Bernoulli's equation. Inside the pipe, pressure difference is created by reducing the cross-sectional area of the flow passage. This difference in pressure is measured with the help of manometer and helps in determining rate of fluid flow or other discharge from the pipeline. Venturimeter has a cylindrical entrance section, converging conical inlet, a cylindrical throat, and a diverging recovery cone. So this one is the Venturimeter. Okay, so meron siyang piezometer. So sa pipeline kasi, di ba constant yung diameter ng pipeline. So the Venturimeter, pinapaliit niya yung diameter at some point. So ito ang tinatawag natin na throat. So ito yung inlet niya, converging, at meron siyang throat dito, then meron siyang diverging outlet. Now, on this part, meron siyang nilalagay na piezometer, and also on this part, then yung different pressure in this point 1 to 2 will be manifested on the piezometer, or in other Venturimeter, instead na piezometer, ang nilalagay nila ay itong differential manometer. So we have already studied this one. This is a differential manometer. Now again, using the Bernoulli's energy equation, now if this is the height of the liquid at this point 1, then of course this is the pressure head P1 over omega. And at point 2, if this is the height of the liquid at this point, this is the pressure head P2 over omega. Now the difference between the two pressure heads, we call that H. Okay, so applying the Bernoulli's energy equation from point 1 to 2 for this Venturimeter, so the equation is similar to other equations that we have derived. We have here at point 1 B1 squared over 2G, then we have the pressure head, the elevation, and also we have here the velocity head at 2, the pressure head at 2, and the elevation at 2. So itong equation, we can simplify this. We can write it this way. The difference in velocity head at point 2 and point 1 is equal to the pressure head at point 1 plus the elevation head minus the pressure head at point 2 plus the elevation head at point 2. Now in Venturimeter, Q1 is equal to Q2. Kung ano yung flow rate dito sa point 1, that must be also the flow rate at point 2. Kasi isa lang naman siyang pipe. Kung ano ang dumadaan dito sa point 1, ganun din ang flow na dumadaan dito sa point 2. So since Q is equal to V times A, so Q1 is equal to V1 times A1, Q2 is equal to V2 times A sub 2, A1 is equal to pi D1 squared over 4, and A2 is pi D2 squared over 4. So pi and pi will cancel. We can rewrite this equation in terms of V2, so that is equal to V1 D1 over D2 squared. Now, if we square this both sides, so V2 squared is equal to V1 squared, and since this is already squared, if we square this, that becomes raised to 4. Now, if we divide this by 2G, the left and the right side, so V2 squared over 2G is equal to D1 over D2 raised to 4 times V1 squared over 2G. Makita nyo yung velocity head at point 2 is equal to the velocity head at point 1 multiplied by the ratio of the diameter of 1, so this is the diameter at point 1, divided by the diameter at point 2 raised to 4. So this equation is useful in so many situations. Now, to compute theoretical QT, yung Q na nagdadaan dito is, theoretically, that is A times the velocity, A sub 1 times velocity, or A sub 2 times velocity sub 2. Now, the actual Q, because of the head loss, so meron niyang konting head loss, siyempre nagkaroon siya ng convergence. The actual Q is equal to C times QT. So itong sing ito, this is the meter coefficient factor due to head loss in the Venturimeter. C is always less than 1. Okay, so ito yung consideration sa head loss dito sa Venturimeter. Now let's go to this example. A Venturimeter having a throat 4 inches in diameter is installed in a horizontal 12-inch pipeline carrying a light oil with specific gravity of 0.82. A mercury U-tube connected as shown in the figure shows a difference in height of mercury columns of 9 inches. The remainder of the tube being filled with oil. Find the discharge Q. Let's see the meter coefficient equal to 0.98. So this is the picture of this problem. So meron siyang pipeline, nilagyan siya ng Venturimeter with a U-tube differential manometer. So the fluid that flowing in the pipeline is oil, the specific gravity is 0.82, and the fluid in the manometer is mercury. So the differential between these two, which is equal to H, is 9 inches. So we are asked to find the discharge along the pipeline. Now let's solve for the Bernoulli's energy equation from 1 to 2. So that is velocity head plus pressure head plus the elevation head at 1, that is equal to velocity head plus pressure head plus elevation head at 2. Since yung pipeline is horizontal, so Z1, the elevation at point 1 is equal to the elevation at point 2. So makancel na tong dalawa. So what is left is this one, and we can write this equation with this one. The difference in velocity head is equal to the difference in the pressure head. You transpose B1 squared over 2G to the right side, and we transpose P2 over omega to the left side. So we can use the differential manometer to find out what is the difference of pressure P1 over omega, the pressure head, 0.1 minus the pressure head at 0.2. So considering this figure, ito yung differential manometer natin, 1 to 2. Okay? So from the problem, it is obvious that the pressure at 1 and 2 are different. So kaya nga tumaas ito dito ng at a height H dito sa manometer. Okay? So deriving the equation from point 1, that is P1. So the liquid of this one is oil, which has a specific gravity at 0.82. So we multiply that with the specific weight of water, 0.036 pound per cubic inch, and this distance here, itong distance papunta dito, this is equal to y plus 9 inches. So itong h, given ito 9 inches, that is given in the problem. The difference in height of mercury column is 9 inches. So since this distance is unknown, lalagyan natin siya ng variable na y. So the total distance from this point to this point is 9 plus y, or y plus 9. So ito yung equation niya. Now from this point to this point, kung alahanin nyo yung solution dito sa differential manometer, itong papunta dito paibaba at itong papunta dito sa itaas at the same distance, magka-cancel out yan kasi ito ay positive. Similar liquid, mercury, similar distances, ito ay negative siya papunta dito, from the bottom to this point is negative with similar distances and similar substance. So magka-cancel siya, positive and negative. So pupunta na tayo dito sa point na ito. Okay, so paitaas siya, di negative uli siya. So kung babalik kayo dun sa manometer reading, ang paibaba ay positive at ang paitaas ay negative. So from this point to this point is negative, that's why we have here negative. And the liquid inside this manometer from this point to this point is mercury, that's why we have here 13.6. So you multiply it by the specific weight of water again. Kasi ang kinukuha natin ditong heads are in, all are in water. So kina-convert natin sa water yung mga heads. So that's why we are multiplying this by the specific weight of water. So from this point to this point is 9 inches. So from this point naman to this point is negative. So we have here oil, that is 0.82 specific gravity times the specific weight again of water times the unknown distance y. So at this point that is equal to P2. So by simplifying this equation, ito, okay, i-multiply ito lang siya dito, distributive law. At ito again, i-multiply natin siya sa 9. So this one here. So this term, we multiply this by y, and this term, if we multiply this by 9, this one remains the same, negative 13.6 and so on, and also this one remains the same, that is equal to p sub 2. Now, kung makikita nyo, meron tayo ditong similar terms, this one 0.82 times 0.036 times y, positive. So, ito ay negative 0.82, 0.036y. So, makancel itong dalawa. Itong dalawang ito kasi parehas lang naman pababa, positive, parehas lang naman na substance, and parehas yung distance. So, ito na yung dalawang yun. Parehas lang yan nung nangyari dito. Hindi na natin sinali kasi pababa, pataas. So, makancel lang silang dalawa. So, if we transpose P2 on the left side, and we transpose this to the right side, so this one, 0.82 times 0.036 times 9, magiging siyang negative. At ito namang 13.6 times 0.036 times 9, magiging siyang positive. Itatransfer natin siya dito sa right side. So ito, wala na to. Saka ito. Then P1 minus P2 is equal to 4.1535 psi. Okay, you simplify this term here. So in terms of oil, we can convert this difference in pressure, P1 minus P2, into pressure heads. So that is P1 over omega of oil, right, minus P2 over omega of oil. That's why we have here P1 minus P2 over omega of oil. Now, the omega of oil, or the specific weight of oil, so ito, P1 minus P2, ito na siya. The specific weight of oil can be found by multiplying the specific weight of water, 0.036, times the specific gravity of oil. So, 4.1535 divided by 0.036, this is in pound per cubic inch, times the specific gravity of oil. So, we have here 140.3 inch of oil, or that is in feet of oil column. So, ang ibig sabihin nito, feet of oil column or inch of oil column. So, 140.3 inch of oil column is equal to 11.7 feet of oil column. Ngayon, kung water column ang hinahanap mo, wag mo nang isali ang 0.82. You just divide this by 0.036. Ang kalalabasan niyan ay inch of water or feet of water. Pero dahil minultiply mo siya ng sa oil, so this now becomes the specific weight of oil if you include this 0.82 here. Now, using this equation, the velocity head at point 2 is equal to the velocity head at point 1 multiplied by the fourth power of the d1 over d2. So, gagamitin natin siya dito sa equation na ito. So, nandito siya, b2 squared over 2g, the velocity head at point 2 is equal to the velocity head at point 1. This is now the diameter at 1 and the diameter at 2. So, 12 and 4 inches. So, this 12 over 4 is equal to 3 raised to 4, or that is equal to 81 b1 squared over 2g. So, itong equation na ito ay ito na siya. Okay, 81 b1 squared over 2g by simplifying this term. Now, from, again, this derived equation, dito, the difference in velocity head is equal to the difference in the pressure head. So, b2 squared over 2g, ito siya, 81 b1 squared over 2g. So, itong value kasi ng b2 squared over 2g na compute natin is equal to the 81 times the velocity head at point 1. So, 81 times velocity head at point 1 minus this one, velocity head at point 1 is equal to, yung na-compute naman natin na P1 minus P2 over W. Okay? P1 over W minus P2 over W. So, this is 11.7 feet of oil. Now, by simplifying, we have here 81 minus 1. That becomes 80. And B1 squared over 2G is equal to 0.146 feet. So, knowing G is equal to 32.2. So, we have here B1 is equal to 3.07 feet per second. So, tatandaan nyo itong G. Value of G in English units, 32.2 feet per second squared. So, this is the theoretical Q. Knowing B1 is equal to 3.07 feet per second, and A sub 1 is 0.7854 feet square. So, nakuha naman natin yan sa given, knowing the diameter at point 1 is equal to 12 inches. So, if you convert the cross-sectional area of 12 inches pipe using diameter equal to 12 inches, so area of 1 is 0.7854 square feet. So, you multiply this, then you have the theoretical Q, 2.4 cubic feet per second. And knowing the value of C, yung meter coefficient factor, that is 0.98. So, you multiply that by 0.98, this theoretical Q. So, the actual Q is 2.36 cubic feet per second. So, the actual Q is lesser than the theoretical because of the head losses along this meter. So, that is our discussion for this particular topic, Venturimeter. We will continue our discussion here and we will take up another application of the Bernoulli's energy equation. So, yan muna. Salamat.